For this problem, we're asked to calculate the magnitude and the direction of the smallest possible force that will produce a 210 inch-pound clockwise moment about B. So we're looking for 210 inch-pounds. We're given the proportions of our lever. And basically, I've drawn it down here. I have the height 22, distance in the x direction from A is 8 inches. We've shown P applied at some angle alpha, and that angle we want to calculate along with the magnitude of the force that will provide 210 inch-pounds clockwise. So looking at this, first off, I could calculate the x component of P and the y component of P and then solve for P, or I could solve for this distance. Right now, P is perpendicular to the distance from A to B, even though there's a dip in my lever. But basically, if P is perpendicular, it will be the smallest possible force because it'll have the longest moment arm. So to calculate that and solve for P, I need to look at the distance, and I need to ultimately solve for the angle here. So I have theta there. I have alpha there. I have theta here. And these two angles will be equal because I've got this perpendicular to this edge, as this is perpendicular. If I close this off here, there'll be similar triangles. So this is the same as this. So we can say that alpha equals theta. And we see our triangle. We can solve for theta. Our tangent of theta is 8 inches over 22 inches. Or 0.3636. We do the inverse tangent. We can solve for theta. Theta is 19.98 degrees. Now that we know that, let's calculate what this distance D is. So the distance from A to B, we'll use Pythagorean theorem because this is a right triangle. So D squared equals and that equals square root of 548, which equals 23.41. So that's D equals. So if D equals 23.41, we know that P times D, we want it to equal 210 inch-pounds. We're given D, so let's solve for P. P equals 210 inch-pounds divided by 23.4 inches. And that equals 8.97 pounds. So we know that our force P is 8.97 pounds. And we know that it is at an angle 19.98 degrees.